good morning. Give this a try. See what you guys can get. Oh, let's do round to the hundredths place. All right, guys. So let's go ahead and take a look at this warm-up. If you guys have questions, we can go ahead and ask those at any time. We will be going over circles and composite shapes today. Just a reminder to all of my seniors that are in this class, remember that your final is June 1st. So this is your last lesson that's going to be on the final. So for all the seniors, what we're going to do is this is your last lesson. So today we're going to learn it, and then we're going to go do the homework next class. And then for you guys, Thursday and Friday, that's really time for you guys to work on that review for the final and ask questions on that. Okay? So the next lesson won't be on the final for you guys. So kind of exciting, seniors, right? This is your last lesson for geometry this year. So very exciting for you guys. All right. Let's go ahead and take a look at what we got going here. So this is going to take a little bit to solve, right? So the first thing I'm going to do is focus on this triangle on the left. So to do this, I'm going to solve for A, B, and theta. So the first thing I'm going to do is solving for theta is going to be really easy. So I know that the angles in a triangle add up to 180. So I'm going to subtract 17, subtract 90, and I get that this angle up here is 73 degrees. Okay, so that's 73 degrees. And I just did that because the angles in a triangle add up to 180 degrees. The next I'm going to do is I'm going to start by solving for A. So I'm going to use my reference angle. So it looks like this would be adjacent, and here I'll write down SOHCAHTOA, right? And I'm going to go through this a little bit more quickly because we have been working on this for a while. So I'm going to have, someone coming in. So I'm going to have cosine of 17 degrees equals A over 15. So if I multiply by 15, I get 15 cosine of 17 equals A. And I'm just going to go ahead and leave it as the exact answer for right now. Okay. And then if I want to find B, that is the opposite over hypotenuse. So that's going to be sine of 17 degrees equals B over 15. So if I multiply both sides by 15, I get 15 sine of 17 degrees equals B. Okay, so those are my two exact numbers. Now again, right, to get the approximate, I would just type that into a calculator. So I'm not going to spend time on that right now because that's just typing it into a calculator, right? I can have my algebra kiddos do that, and you guys can do that, okay? So next up, I'm going to look over at the next triangle. So if this is 90, right? Because this is a linear pair, right? And we remember that a linear pair add up to 180. So if this is 90, this has to be 90 because 90 plus 90 is 180. The cool thing is we know B, right? So the first thing I'm going to do is I'm going to find angle phi. So we know the angles in a triangle add up to 180. So if I go 180 minus 20 minus 90, I get 70. So that means this angle up here is 70 degrees. Okay, so I get my angle. Now, if I want to get the precise answer, I'm going to use exact answers down here. So for example, let's say I want to find angle C first. So to find angle C, that's adjacent and B is opposite. So that's going to be a tangent. So I can say tangent of 20 degrees equals my opposite, which is B. So that's 15 sine of 17 degrees over my adjacent, which is C. Okay, so notice how, right, this is B. But I didn't use, do you guys see how I didn't use an approximation? I used the exact answer. And yeah, it looks uglier, but your calculator doesn't care how ugly it looks, right? Your calculator will do it just fine. So I solve for C. I multiply both sides by C. But then I have C times tangent of 20. So I divide both sides by tangent of 20. So tangent of 20 degrees, like this. So I get C equals 15 sine of 17 degrees over tangent of 20 degrees. And this is my exact answer right? There's no rounding. There's no, right? I haven't used a calculator. You can do this without a calculator. Boom, there it is. Okay, and I think some people get so focused on the calculator use, the exact answers are really easy to find. And this isn't harder to do in a calculator, right? Yeah, you got to hit a couple more buttons, but it's easy to type in. Now, I'm going through this and no one has asked a question yet. So are we doing okay, guys, so far? Are people okay with this, how I did that? Yeah, so I think some people in the last assignment were struggling because they were getting rounding errors, right? Like they were getting the answer, but they were off by 0.1. Well, if you do it this way, right, there is no rounding error. You just type it into your calculator, you're good to go. So the last thing I have to find is D. So if I go here, I'm going to use B again. So 20, this would be opposite and hypotenuse. So that's sine. So I'm going to say sine of 20 degrees equals my opposite, which is 15 sine of 17 degrees over D. Now this one, oops, sorry, I wasn't in the picture there. Sorry, I got someone coming in. So so in this case, I can almost, right, since I know it's the same setup here, it's going to be the same. It's going to be D equals 15 sine of 17 degrees over sine of 20 degrees. Okay, it's going to be in that same format. So again, and I really want to stress this. I know some of you guys are going to go on to do math, and some of you guys are like, hey, I don't want to really do much math after this, right? We're all in different places. But for those of you guys who are going on to more math, being able to solve it and get it all done so that you can just type it into your calculator at once is going to save you time. It's going to reduce the amount of mistakes, and it's just going to make your life so much easier. So this is a really good practice at, can I do this? Can I get all the math done and just type it into the calculator all at once? Okay, so we don't have to worry about rounding until the end, right? And that's what we want to do. So hopefully I thought this warm-up would be helpful for people, because I know on that last homework assignment, some people were struggling with the rounding of numbers and getting exact numbers, etc. Okay, so does anybody have questions about this before we move on? And I could, right, I can find the exact, but I just think at this point, since we practice this so much, that's not a good use of our time. Okay, so I hope this was helpful. I know some people were getting frustrated. All right, let's go ahead then. So 11.1, the first thing we're going to talk about is we're going to focus on circumference. Okay, so let's talk about circumference, and let's talk about the parts of a circle. So the first thing we should talk about, a circle is very different. Now, due to COVID, we're going to have a very shortened look at what a circle is. But circles are really important, and we talked about this in trig a lot. We talked about how, as a matter of fact, right, every point on a circle, right, so if this is a point on the circle, can be written as a right triangle, where this is x and this is y. And that's where trig is a circle, is that every point on a circle is a triangle. And I've been trying to sell that to you guys, and I know some of you are interested in that and some of you aren't, and that's okay. But it is really interesting, like, how the heck is a circle a triangle? Well, that's it. A right triangle is in every point. So what's important is, in a circle, right, we call this a radius, right? So R is our radius. And a radius, right, is from the center to the circle. Okay, so I can zoom in just a little bit. No need to strain our eyes there. So the radius is from the center to the circle, right? So I can even add that in, right? So I can call this right here, we can call that C for center, right? It's the center of the circle. And it's important to note the center isn't the circle, right? So the center is not on the circle, okay? The center is the center of the circle. So the radius goes from the center to the circle. Okay, and I'm sure some of this is review for you guys, but I'm just double checking. Okay, now if we have this go all the way across, right, then this is also a radius on this side. Okay, but more importantly, the whole thing like this, this is called d. And d is the diameter. Now, the diameter, right? So the diameter is all the way across. So there's a couple of different ways to think about diameter. So the diameter equals 2 radii. Or you can think the diameter goes all the way across a circle while going through the center. Sorry, that was a lot of writing. Let's pause to get all that down. So it goes all the way across a circle while going through the center. Now, again, I feel kind of bummed. We are throwing. This is a shortened look at circles, but a word that we're skipping is a diameter is a special type of chord, and a chord is just a segment that connects 2 points on the circle. So you can think of a diameter as just being a segment that connects 2 points on a circle that also goes through the center. Okay, that's what would be the more formal definition of that. Okay, but we don't need to know that for this year because we're going on a tightened timetable. Okay, so these are kind of the basics. You probably have learned about this before. I just wanted to get it into your notes, right? We have a radius that's from the center to the circle, and then a diameter is 2 radii, right? Remember, in English, right, if it ends in US, you drop it and you add another I, so it's radii. Okay, and it's a very, that and if you have troubles remembering that, just think, how would Americans do it? And Americans would say, it's not us, it's I. So there you go. Right? There's a little joke about Americans. All right, so this is kind of our fundamental starting point. This is our jump off point. Okay, so we have to know these things. No one's asking any questions, so I'm assuming that you guys are doing okay with this, and I hope that was enough time to get this all down, okay? So there's circumference. So what's the circumference? So the circumference, and we usually call it C, is the distance around the circle. Now, math can always be confusing with words, right? But a circle is so important in the history of mathematics that it gets its special name. But circumference is basically just perimeter. Okay, and you can add that to your notes. I'm not going to because in the past that's confused some people, but you can add in there. Circumference is just perimeter for circles. Okay, so if we had a rectangle, right, perimeter would be the distance around the rectangle. Okay, but in a circle, it's called circumference. So circle, circumference, any other shape, perimeter. Okay, so it's the distance around the circle. Now, you guys might heard of a really cool number called pi, and pi is a really cool number. Now, pi, there's a couple of different ways to come up with the number of pi, but the classical, the first one where people noticed it, was it is, circumference divided by diameter, and that equals pi. So that's just a cool thing. That's like the original OG definition. Circumference, so the distance around the circle divided by the distance from one point to another point that goes through the center. That's the definition of pi. And it was just crazy because and it should be crazy. This should be blowing your mind, right? It doesn't matter what the distance around is, and it doesn't matter what the diameter, it will always be pi. It's this ratio that is always pi, and this is in any circle in nature, okay? But we like to think of circumference equaling pi times the diameter. Or, right, because diameter equals 2r, we sometimes think of it as 2 pi r, because the diameter equals 2r. Now, why do they write it like 2 pi r and not pi times 2r? Guys, I don't know. all I know is that that's become the standard. Okay, and I'm sure there was like some silly reason for it, but it's just like that's how people write it. So if you want to Google this is how it's probably going to show up on the internet. Okay, so now I'm not joking, guys. You have to have this down. This is going to be seniors. This is going to be on your final. Everyone else, this is going to be on your final. It's going to be on your homework. Just write it down. This has never been easier because you don't have to memorize this. Okay, so just make sure you have this in your notes and you're good to go. All right, and then we'll practice this in a little bit. But for right now, have it in your notes and we're going to come back to it later. So anytime we have something that involves radius or diameter or circumference, you'll be like, okay, cool, I have this. Okay, actually I lied. Let's go ahead and let's do a couple of example problems. Let's do just one example problem and we'll go from there. Okay, so let's take a look. Let's do an example. And let's say find the circumference if r equals 9 centimeters. Okay, so we're going to find the circumference if r equals 9 centimeters. And what I'm going to say is, so you can find the exact answer. So the exact answer is going to have pi in it. Okay, so you just leave pi in it. And then we're going to find the approximate answer, right, is where you have to round it. So why don't you guys try that out? Try that out on your own. Here, take a minute. Try that out. Found the circumference if r equals 9. So find the exact and the approximate. And I'm not trying to trick people. All right, and again, if you guys have questions, let me know. So in this case, right, so it says find the circumference. So I'm going to say I need an equation that has circumference and radius in it. So, right, I'm not using this top one because it doesn't have radius in it. So I'm just going to find the equation that has circumference and radius in it. And then I'm going to replace the radius with 9. So I'm going to have circumference equals 2 pi times 9. So all we have to do here for the exact answer is what's 2 times 9? Well, 2 times 9 is 18. So I get circumference equals 18 pi. So this is our exact. That's how easy it was to get the exact. And then in our calculator, I can't stress this enough, you never ever want to round pi. There is a pi button on your calculators, whether you're using a physical calculator or Desmos. So we're going to say 18. This calculator, pi is right here. And then I'm going to hit enter. Now this calculator is kind of annoying. It only tells me that. So I'm going to go like this. And I get my exact answer. Here, I'm going to go over here. Is C is approximately 56.55 and then centimeters. Okay, because it is a distance. Notice how my radius was a distance, my circumference is a distance. So it's 56.55 centimeters. Okay, does anybody have questions there? Right, and hopefully this was straightforward. So if it's not straightforward, let me know, because if no one says anything, I'm just going to assume that it was straightforward. And I appreciate the feedback, guys, I really do. Thank you so much. Okay, So then let's do a second one. So here's part B of this. Okay, so we're going to find the radius if the circumference equals 26 meters. Oop, there we go. So down here in the bottom, right here, find the radius if circumference is 26 meters. And I'm going to have you guys get a minute for that. So find the circumference, find the radius if the circumference is 26 meters. So you're going to have to do a little bit of algebra here. Find the exact and the approximate answer. All right, so again, let's go through this. So I want to find radius, I want to find circumference. So I'm gonna look at my equations in my notes, and I'm gonna pick the one that has circumference and radius in it. So I have circumference equals 2 pi r. Well, I want to find the radius, and I know the circumference. So in this case, I know that the C is 26 meters, and then I have 2 pi r. Now, a lot of people get thrown off when we start using symbols, but you can't be thrown off because remember, algebra works, and it works regardless of what it looks like. So I need to get r by myself. So what do I have? I have 2 times pi times r. So it's all multiplication. So all you have to say to yourself is, how do we get rid of multiplication? Oh, we divide. So I'm just going to divide both sides by 2 pi, right? 2 pi goes into 2 pi one time, so we get r equals 26 meters divided by 2 pi. That is our exact answer. Kind of cool, right? That's it. Like, so exact is way easier, right? Now I'm going to have to get my calculator for the approximation. So I'm going to have 26, right? There's no units in these calculators, so we leave the m off. How do you want me to move the paper? Can you on my screen this shows up right here. It just shows up. Are you guys not seeing that? Okay. So and then I divide by 2 pi. Right? So again, you never want to approximate. Don't use 3.14569 whatever, 3.14159. Don't use an approximation. Don't. I know people think memorizing pi is cool, but it is never useful. Always just use the exact version of pi. Okay, I'm going to hit enter, and I'm going to get r is approximately, so in this case, if I go to the second, I'm going to round up. So it's approximately 4.14 meters. Okay, so I have my exact, and I have my approximate. Okay, so tomorrow in our practice time, there's going to be some questions that are going to ask for like, hey, given this, find this. So you're going to have to take these equations, right, that you don't have to memorize, but you're going to have to use algebra to solve for different pieces. Okay, yeah, you guys can totally do this. And I think the biggest thing for a lot of people is that we're just not comfortable moving symbols around, like moving pi around. So it just takes a little bit to reprogram our brain and be like, hey, it's totally okay to move symbols that aren't numbers. And that just takes getting used to, because with new things, sometimes it's just a matter of getting used to it, okay? All right, well, guys, that's all we have for 11.1, okay? So that's all we have for 11.1. So what we're gonna do now is we're gonna do 11.2. Right, and that's why we're doing two in one today, because that one was really short. Okay, so 11.2 has to do with area of shapes and composites. Composites. Sorry, that's an O. Composites. Okay. Areas of shapes and composites. Yeah, you could find D really easily, right? And in some cases, right, they might say, hey, if diameter is this, what's the circumference? I'm totally with you on that. So 11.2 is area of shapes and composites, okay? So the first thing we're going to do is just, again, everything is open notes. So things this year are very nice indeed, right? So we're just going to go over some basic shapes that in reality you guys should have memorized. So the first one is the area of a triangle. Okay, so if you have a triangle, it's going to have a height, h, and it's going to have a base that is perpendicular to that height, b. And the area of a triangle, so I usually do A, and I do like little tiny subtext. So the area of a triangle equals 1/2 the height times the base. And if you ever wondered where this equation comes from, a rectangle, right? If you draw a diagonal in it, it's two triangles. So a triangle is, every triangle is just half of a rectangle. Kind of cool, right? Or a square, but yeah, rectangle. Anyways, you guys are like, oh, that's so cool. Yeah, I get it. It is pretty cool. All right, so that's one that you need to know. The next is a rectangle, right? That has a length and a width. The area is length times width. Now, I'm not going to teach a square because a square is just a special rectangle, right? So if this is a rectangle, right? If L and W are the same, you still just multiply them, okay? And then the last one that you really should have memorized is a circle. And the area, oops, I didn't write, right? So this is area of a rectangle. The area of a circle is pi times radius squared. Okay, and that's not 2 times the radius. That's not the diameter. That's radius times radius. Now, unfortunately for that one, you're going to need, to get that precise one, they use a little bit of calculus to get there. So I know before calculus they had an approximation and they figured it out just through guess and check. But to really prove it, you need that calculus, because it turns out it's the integral of area. I mean of the length. All right, so these are areas that you just need to know. You got to just know them. Okay, now luckily for you, you guys have open notes, so it's going to be even easier. But let's be real. You guys need to have these memorized. Like these should be like, yeah, I know these, done them before, we can do that. Okay, so those are the areas you just need to know. I'm gonna just make sure people, so I know some people, everyone takes notes at different speeds, so just want to make sure you guys get those in there, because especially for my seniors, wink, 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 your test is coming up soon. You guys are gonna have to need to know these. Okay. All right, so let's do some examples of these, and then we'll get into composites, and then we'll be done for today. I gotta turn off this. There we go. All right, so let's do a couple of different examples. Okay, so I'm gonna focus on circles, just because I know you guys have done a lot of triangles and rectangles in your life. So we're going to do find the area of a circle whose radius is 2.5 centimeters. Now, I don't think we need a minute to do this, so I'm just going to do 30 seconds. So take 30 seconds, and find the area of a circle with a radius of 2.5 centimeters. And where you guys are going to make mistakes are the units. So be careful on the units. Okay, so this is the big reminder. We have to remember units, units, units. Look at all of these things. In all of these areas, you're having a length times a length, right? So a height times a base, a length times a width, the radius times itself. So think about that in terms of units. If you have centimeters times centimeters. So this is going to be the area of a circle equals pi times radius squared. So when I write this in, this is where units really matter. This is going to be pi times 2.5 centimeters squared. Notice how the centimeters, this is so important, guys. When we get to area and volume, and that's what we're going to be doing for these last bit of lessons, depending if you're a senior or not. Okay, the centimeters get squared as well. So when I do this, I'm going to go, now your calculator doesn't do units, but it does do 2.5 squared. So I'm going to get this equals, now you can put the number in front, 6.25 pi, and then it's centimeters squared. Okay. It is centimeters squared. It's area, and area is squared. If you've ever gone to a hardware store and they're like, well, how much paint do you need? Like, what's your square footage that you're painting, right? Your square footage, because area is squared. It's units squared because you're taking a length times a length. Okay, does that make sense to everyone? Are we doing okay there with the units? Area is squared, and because you're doing a length times a length, okay? Now, we can do this approximately. It's kind of silly, but just remember, don't approximate pi, okay? And then we get, which is approximately 19.63 centimeters squared. Okay. So again, this was really basic. I'm just trying to get you guys to remember the equation, right? Remember it's units squared, and to go from there. So this next one is going to be a little bit more interesting. So we're going to find the diameter. So we're going to find the diameter of a circle. Oops, am I off there? I am. I'm going to find the diameter of a circle with area of 113. That's what I meant to write down. 113.1 centimeters squared. So this one's going to be a little bit more difficult, so I will give you guys a full minute to do this. So again, we're going to find the diameter of a circle given that the area is 113.1 centimeters squared. So we're going to have to work backwards, and when working backwards, that means we're going to have to do a little bit of algebra. All right. So how do we do this? So again, it's a circle. So I know that the area of a circle equals pi r squared. Now, the first thing I noticed, see how this is r. We can't just, this isn't 2 times r, it's r squared. So we know that the diameter equals 2r. Right? So what I would do, now there's a couple different ways you can do this. You can solve for r and then multiply it by 2 and you have your diameter. Or you could say that the diameter divided by 2 equals r. Either way is totally fine. So again, at the end, you could solve for r and then just multiply by 2 at the end, or you could say that half of the diameter is one radius. And that's what I'm going to do. I'm going to say the area of our circle here is pi times the diameter over 2 squared. Okay? Either way works. Everyone's going to have a different comfortable way of doing this, but you can either solve for r and then just multiply by 2 at the end, or you can do the hard work first. And I like doing the hard work first. So the area is 113.1 centimeters squared times pi times d divided by 2 squared. So we're going to solve this. And then we have to think, right, PEMDAS. So I have to do parentheses, then exponents. Well, so my first parenthesis here is I'm going to divide by pi. Okay, go like that. So I get 113.1 divided by pi. My goodness, don't put this into a calculator. Okay, so we get d over 2 equals, or d over 2 squared. Then, only then, are we going to want to get rid of the square root. So I'm going to square root both sides like this. That's going to go away. Now, normally we'd have a plus or minus, but we don't care about the plus or minus when we're finding a length. Now, again, my goodness, don't type this into a calculator. Way too much work. Okay, so I want to get the 2 off the bottom, so I multiply by 2, and I get 2 times the square root of 113.1 over pi equals the diameter. And that is my exact answer. This is my exact answer. Now, you can always go ahead and type this into a calculator, right? I could go 2 times the square root, the square root of, and then I do a fraction, 113.1 over pi, right? I can type that into a calculator and I get, it's approximately 12, right? So D is approximately 12. Which is kind of cool, right? That's pretty close to 12. Oops, I didn't put units. 12 centimeters, yeah. So again, it's a length, so it's just in centimeters. Guys, I thought that was a pretty difficult problem. Does anybody have questions or concerns about what I just did? Right? The first one was really straightforward. The second one, do you guys see how it got really difficult really quick? There was a lot more. Oh, good. I'm glad that you saw. You figured that out. It's a lot more difficult, right? There's a lot more steps. So these problems go from really easy to, oh my gosh, I got to do a lot of algebra, right? So I would say this is more of like a middle school standard, but this is the high school stuff, right? Being able to, oh my gosh, I got to move things around to solve for them and figure things out. Notice though, I never want to round until the very end. If you start rounding from the very beginning, by the time you get here, you're going to have a different answer. So don't round until the end. Don't round until the end. Okay. No one else seems to have any questions. I thought for sure people were going to have questions, but if this means everyone's getting it, then this is really good. This is really good. Okay. We only have one more thing left that we're going to do today. We're moving pretty quick because people aren't asking questions. So I'm a little worried about that. So let's go ahead and take a look at our last thing, okay? So area, this is just a couple examples here. So areas, you need to know your areas, Okay, there's going to be some circle questions that are going to be a little tricky because we're not used to working with circles, right? So dealing with diameter, radius, and circumference. Okay, so let's go ahead now, since no one's asking any questions. Let's take a look at composite shapes. Okay, so composite shapes. So I don't know if you guys ever heard the word composite before, but composite is a common English word that's used in a lot of different scenarios. So you might have a composite plastic or a composite metal. Those are two situations where it's used a lot. So if you guys are in shop, right, you need to know that, like if you're welding or building, right, or like 3D printing, right, what you're using with. So composite, what it means is it means two or more. Okay, so when I say composite shapes, I'm talking about shapes that are comprised of two or more things. Now, we've talked about this before with like video games, but the way video games and 3D modeling works on the computer is everything in a 3D model is a composite shape, unless you're just looking at a triangle, which most people don't. But what it is a whole bunch of shapes put together to make a new shape. Okay, and this is really helpful because we spent almost all of our school year looking at triangles. And the idea is we can get almost any shape with just triangles, right? Because a rectangle is just two triangles. Now, a circle is a whole bunch of triangles, so that's a little bit different, and that's why we're focusing on that today. So what happens when we put two or more shapes together? Okay, and I'm just going to go ahead and just do some examples, okay, of what we're going to do with composite shapes. So here's an example here. Okay, you're going to find the area of the composite shape. Okay, so we're going to find the area of the composite shape. And here's my hint. Find the area of each smaller shape, then add them all up. Okay, so that is my advice. Find the area of each smaller shape and then add them all up to find the area of the total shape. And this is a technique, guys, that goes all the way back to like the earliest records ever, right? So to find the area of complex shapes, rather than just trying to find the area of the complex shape all at once, just go ahead, break it down into smaller pieces, and then add them all up at the end. Okay? So, a really popular problem here, and we're not going to do the hard mode of this, is a door with a window on the top. Okay? Or you can think of this as a bullet. Okay? Either way, I was trying to be non-violent there. Okay, so let's say this distance is 16 feet across. Okay. And this distance is 10 feet. I want you to find the total area. Now, I'll give you one hint. That top shape, right? It looks familiar. It's half a circle. Okay, right? So that top shape is half a circle. So let's take 2 minutes. Let's take a look at this, and we'll call it. This will be where I think we're going to run out of time. So I want you to find the total area, right? So you think, what two shapes do we have there? It looks like a half circle, a half of a circle, and a rectangle. So let's take a look. How would you guys find the area of this? So it's a half circle and a rectangle. Yes, 16 is the diameter. Now, unfortunately, guys, I have to go over this. So what I would do here is I would label these. I have shape 1 and I have shape 2. So shape 2 is really easy to find. So I'm going to start with shape 2. It is just the area of a rectangle is length times width. So I'm going to have the area of this rectangle is going to be 16 times 10. So 16 times 10, that is 160 feet squared. Okay, so that is the area of that rectangle. Now, the area of the half circle, so it's half a circle, right? So it's half circle, is going to be 1/2 pi r squared. Now, someone pointed out, sorry, that is in the way. Someone pointed out that they don't give us the radius. They give us d equals 16. So that means the radius is going to equal 8 feet. So if the total diameter is 16, the radius is 8. So I'm going to have 1/2 pi times 8 squared. So I'm going to grab this. 8 squared is 8 times 8. Why can't I think of that? 64, right? Okay. And then half of that, right? So this is 1/2 64 pi. So half of 64 is 32. So the area equals 32 pi feet squared. So then at the very end, for the total, I'm going to have the 160 feet plus the 32 pi feet squared. Sorry, they're both squared. Okay, so you're going to add those together. So I'm not going to round until here. I'm going to go 160 plus 32 pi, and I get it is approximately 260.53 feet squared. All right. Sorry, guys. I'm a little bit over. Have a great day. I'll post this. We'll work on this tomorrow. Bye, everybody.